All right, let's take a look at the practice test where the instructions were asked to write a polynomial function of least degree that has the given zeros. All right, before we get into any problems today, I want to take a few moments and go through some of the formulas that you can use to greatly speed up your work. I'm going to start with something we should already know. So if we multiply two complex conjugates together, so let's say something like a plus bi and then times a minus bi, we should know already that this is a squared plus b squared. So that's going to be a real number. But in case you want to go through this the long way, again, if you just use FOIL, a times a is a squared. The outer and the inner would cancel. So you would have a times negative bi, that's negative a bi, and then plus you would have bi times a, so a bi. So again, that's just going to cancel away. And then lastly, you would have bi times negative bi, so that's negative b squared I squared. Well, what is I squared? That's negative 1. So that's going to flip the sign here. So we can say this is equal to a squared plus b squared. Okay, so this is just something you want to remember. And let's put this here that this is a squared plus b squared. So something you might not have looked at, let's say you add two conjugates together. So let's say you have a plus bi, and then you add a minus bi. Well, what does this do? You have a plus a, that's going to be 2a. And then you have bi plus negative bi, so that's going to cancel. So this is just going to be 2a. So keep these two things in mind here because I'm going to show you something else. And this is the only formula you really need for today. Let's say we have x minus, and I'm going to put in here a plus bi, and then I'm going to close this down. And we multiply this by x minus, so we want the conjugate of this, so a minus bi. Close that down and then close this down. What is a quick way to do this? The slow way would be, okay, I'm going to write this as x minus a and then minus bi. So that quantity times the quantity x minus a and then plus bi. In other words, the slow way is x minus a minus bi and then times x minus a plus bi. You don't need to do this. This is going to take a long time and it's going to be quite tedious. So I'm going to erase this and I'm going to erase my equal sign for right now. And I'm just going to do this in the simplest way possible. And that is by making a substitution. You can do it without a substitution, but every time I do it that way, people tend to get lost. So I'm just going to let something like u be equal to this a plus bi. And then I'm also going to make a substitution here. So we'll use w for this a minus bi. Let's say that I write this again using these substitutions. So I'm going to say that I have x minus, this is u, again, that's a plus bi, and this is x minus a minus bi, that is w. Well, what's going to happen if I multiply these guys together? I'm going to get x squared, and then I'm going to get minus wx, and then I'm going to get minus ux, and then I'm going to get plus uw. Okay, let's think about some things that we already know. Let me slide down. I'm going to try to fit all this on the sheet at one time. The first thing is I can factor out a negative x here. So in other words, I could write this as x squared and then minus x times the quantity w plus u and then plus uw. If we think about what is w plus u, again, we've already done that. This is w, this is u. So we're just adding the conjugates together, so we know that's going to be 2a. So this right here, I'm just going to arrow to it and say it's 2a. And then we know what uw is. That's me multiplying the conjugates together. So that's a squared plus b squared. So this right here is a squared plus b squared. And maybe I could make that a little bit better. Okay, so using this information, let me get rid of this and let me come up here and say this equals, well, this would be x squared, and then this would be 2a here times negative x. So minus 2ax, and then basically you'd have plus this a squared plus b squared. Okay, let me get rid of this. This is the formula that we're going to use today to greatly speed things up. I would strongly advise for you to write this down. I'm going to reference it all the time, and I'm just going to roll through these things because trying to do it the slow way is going to take a very, very long time. All right, for problem 1, we have zeros of negative 1 with multiplicity 2, and then we have 1 minus I. So from the conjugate zeros theorem, we know that if we have a non-real complex zero, such as 1 minus I, then its complex conjugate is also a zero. So 1 plus I. So non-real complex zeros, common conjugate pairs. So this means that our polynomial function is going to have 4 zeros. So we're going to set this up as f of x is equal to a, that's some leading coefficient, times the quantity x minus k sub 1, times the quantity x minus k sub 2, times the quantity x minus k sub 3 times the quantity x minus k sub 4. So we're just going to plug in here, 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 and here. Again, the zeros that you plug in, they can go in any order. In terms of a, in the last section, we were given information to figure out what that was. This is just a leading coefficient. In this section, because the problems are more tedious, they typically just leave it off and say, well, you can just make a 1. But really, you could use any non-zero real number that you want, and it would still work out in terms of getting the correct answer. I'm just going to use 1 for simplicity, and I'm just going to leave it off when we set this up in the future. Okay, so I'm just going to follow this and plug in. So f of x is equal to, so the quantity, x minus, again, k sub 1. So pick any of these zeros. Let's just pick -1. So x minus a -1 is x plus 1. And the multiplicity here is 2, so let's just say this is quantity squared. And then for this one and this one, again, just pick these. So let's go x minus. Be very careful when you plug this in. So you want to subtract the whole thing away. So we're going to use some parentheses here. So let's go 1 minus I. Close that down. And then we're going to close this down. And then we're going to do this. So we're going to go x minus, and then this guy right here. Again, it's going to be 1 plus I. So 1 plus I, close that down, and then close this down. Now, again, I gave you a formula for multiplying these guys together. So we're just going to use the formula. So we're going to blow through this really quickly. If you don't know what the formula is, go back to the beginning of this video. Okay, so let's slide down here a little bit. And I'm just going to say that this is equal to, this guy right here squared would be x squared plus 2 times this guy times this guy. So that's 2x. And then plus the last guy squared, 1 squared is 1. So this right here, again, I'm just going to do it really quickly. This would be x squared. And then you're going to have minus 2 times a times x. Now, what is a? A is going to be 1 here. So 2 times 1 is 2. So this is just minus 2x. Then you're going to have plus. So this right here is going to be a real number. So you have a squared plus b squared. So for our purposes, let's just say that a is 1 and b is 1, so 1 squared is 1. So in other words, you would have 1 squared plus 1 squared, again, coming from that formula that we talked about earlier. So 1 squared is 1 in each case, and so you would basically have 1 plus 1, which is 2. Let's just write this as a 2 and close that down. Okay, so now we know how to do this. We're just going to take each term from this polynomial, multiply it by this polynomial, and then combine like terms. So let's start with x squared times this guy right here. So x squared times x squared, that's going to be x to the 4th power. Then you're going to have x squared times negative 2x. So that's negative 2x cubed. And then x squared times 2, that's going to be plus 2x squared. Now we're going to move on to this one right here. So we have 2x times this guy right here. So we have 2x times x squared. So that's plus 2x cubed. And then 2x times negative 2x, that's minus 4x squared. And then 2x times 2, that's going to be plus 4x. So last guy here, it's real easy because we have 1. So 1 times anything is itself. So you can really just copy this. So plus x squared minus 2x plus 2. Okay, let me get rid of this highlighting here. And we're just going to combine like terms. So we're going to say this is x to the 4th power. You have negative 2x cubed and plus 2x cubed. So those are going to cancel. You have 2x squared minus 4x squared. So that's negative 2x squared. And then you have plus x squared. You could write that as plus 1x squared if you want. So negative 2x squared plus 1x squared, that would be negative x squared. Then you have 4x and then minus 2x. That would be plus 2x. And then you have plus 2. So this x to the 4th power minus x squared plus 2x plus 2, that's what you want. Let me get rid of this. So this is one way to write it, but the other way you could say f of x is equal to x to the 4th power minus x squared plus 2x plus 2. All right, for problem 2, we're given zeros of negative 5 and then 3i. We know that if 3i is a 0, then negative 3i, so the complex conjugate, is also a 0. So come down here and set this up. We're going to go f of x is equal to, again, for a, the leading coefficient, you can just leave that off. You could just pick 1, or you can pick any non-zero real number that you want. So I'm going to say that this is x minus whatever the 0 is that I'm plugging in. So here it's negative 5. X minus the negative 5 is x plus 5. And then here you would have x minus, so you have a 0 of 3i. And then here you would have x minus, this is negative 3i, so minus a negative 3i is plus 3i. This one's pretty easy to simplify. So we can just go through and say that this would be x plus 5 times, this one again, if you want to go back to your formula, it would be this guy squared. So this is x squared. And then again, you're going to have a plus here, this 3 here squared, so that would be 9. And again, that happens because I squared equals negative 1, so it flips the sign. Okay, so this one right here, you can go through and simplify really quickly. So x times x squared would be x cubed, and then plus you have x times 9, which is 9x. And then you're going to have 5 times x squared, which is plus 5x squared, and then plus 5 times 9, which is 45. I would just switch the order of these. So let's say that this is x cubed and then plus 5x squared plus 9x plus 45. And at that point, we're good to go. Let me erase this scratch work here. Let me fix that and say f of x is equal to x cubed plus 5x squared plus 9x plus 45. Or again, if you want to list it like this and move on, that's fine as well. All right, for problem 3, we are given zeros of 1, -1, and then 2 minus 2i. So again, if 2 minus 2i is a 0, that means that 2 plus 2i is also going to be a 0. So let's go ahead and set this up. So let's say that we have f of x is equal to, again, for a, I'm just going to use 1, so you can leave that off. We're going to have x minus, one of the zeros is 1, and then we have x minus a -1 is plus 1, and then we have x minus, we're going to throw in 2 minus 2i. Be very careful here. So we're going to put this inside of parentheses. So 2 minus 2i, close that down, and then close this down. And then here we're going to do x minus, again, let's put some parentheses here. So 2 plus 2i, and let's close that down. And then we're going to close this down. Okay, let me see if I can slide this over so it fits a little bit better. Now, what you want to do is use your formula for this. Let me start with this one though. X minus 1 times x plus 1, just use your formula. That is x squared minus 1. So let me wrap this in parentheses. And then for this one, again, we know it's x squared minus 2 times a in this case is 2 times x. So minus 2 times 2 times x. Well, 2 times 2 is 4, so this is minus 4x. Just like that. And then you're going to have plus, again, your a squared. Let me write this out. So a squared plus b squared. Again, just coming from that formula. So we're going to just use an a value of 2 and a b value of 2. So 2 squared is 4. And we can just put that this would be 4 plus 4, which would be 8. Okay, so this would be 8 here. And again, using that formula is just going to save a lot of time. So let's go through and multiply now. So x squared times x squared, that's going to be x to the 4th power. X squared times -4x, that's going to be minus 4x cubed. X squared times 8, that's going to be plus 8x squared. Then this is -1 here multiplied by this. You're just going to change the sign of everything. So this is negative x squared. This is plus 4x. This is minus 8. Okay, so looking at what we have here, this would be x to the 4th power minus 4x cubed. And then 8x squared minus x squared, that's plus 7x squared. Let me fix this x right here. And then you have plus 4x and then minus 8. Okay, let me get rid of this. Your f of x could be written as this, or again, if you want to simplify, you could say it's equal to x to the 4th power minus 4x cubed plus 7x squared plus 4x minus 8. All right, let's take a look at problem 4. So here we're given zeros of 4 and then 2 plus I. So again, that means we're going to have 2 minus I as a 0. And so let's set this up. So we have f of x is equal to the quantity x minus 4 times the quantity x minus. And I'm just going to wrap this in a different color. So 2 plus I, let's do that like that. And then this would be over here times x minus, and then let's say this inside would be 2 minus I, close that down, and then close this down. So again, if you want to simplify, we're going to just use the formula. Let's keep this out in front. So x minus 4. This one here is x squared minus 2ax. What is a here? It's going to be 2. So this would be 2 times 2, which is 4. So minus 4x here. Let me scooch this down. And then plus, again, this is a squared plus b squared like that. And so what is a? We're going to use 2. And for b, we can just use 1. So let's say 2 squared is 4. And 1 squared is 1. So 4 plus 1 would be 5. So let's put this as a 5 here. And again, we can just go through and say x times x squared is x cubed. And then x times negative 4x is minus 4x squared. And then x times 5, that's plus 5x. Then we have negative 4 times this guy right here. So we would have negative 4 times x squared, that's negative 4x squared. And then negative 4 times negative 4x, that's plus 16x. Then negative 4 times 5, that's minus 20. Okay, so let's look through this and say that it's x cubed. We have negative 4x squared minus 4x squared. That's going to give me negative 8x squared. We have 5x plus 16x. That's going to be plus 21x. And then we have minus 20. Okay, let me get rid of this right here. And let me scooch this up like this. So we'll say that f of x is equal to, again, you could list it this way if you want, or you could say it's x cubed minus 8x squared plus 21x minus 20. All right, for problem 5, we are given 3 plus I as a 0, and we're told that the multiplicity is 2, and then we're given 3 minus I. Well, again, if this is 3 plus I with multiplicity 2 by the conjugate zeros theorem, then you would have 3 minus I also with a multiplicity. I'm just going to abbreviate that. That's going to be 2. So when you set this up, you could say f of x is equal to let's go x minus, let's go 3 plus I, close that down and close this guy, quantity squared. And then you're going to have x minus, now you're going to have this guy. So you can have 3 minus I, and then we're going to have quantity squared. Okay, this one is going to be pretty tedious. Let me actually copy this, and I'm just going to come to another page here. Let me write the f of x back in there, and maybe that could be better. So we should know that if you have something like m squared times n squared, you could write that as m times n squared. So this is something we talked about earlier in the course. We're going to use that here, and we're going to say this is equal to, you could use brackets or whatever you want. So I'm going to throw this in here. So the quantity x minus, and then you have 3 plus I here. Just be real careful with your parentheses. Maybe I'll just highlight that. And then over here, you have x minus 3 minus I inside there. Again, let me just highlight this for clarity. And then we're going to close this down and square it. So on the inside, you can just use that formula. So let's go ahead and say that this is equal to, let me put the brackets here. So we know that this is x squared and then minus, again, let me just write this out. So 2ax and then plus you have your a squared plus b squared. So this is something, again, you just want to write over and over and over again. It's really going to help you out today. So what is a? A is going to be 3. So 2 times 3 would be 6. So this is minus 6x. Again, a is 3. So a squared, 3 squared would be 9. And then b, you could just use 1. So 1 squared is going to be 1. And so 9 plus 1 is going to be 10. So that's this guy right here. And let me scooch this down. And I forgot to square it, so let's square it now. So if you had x squared minus 6x plus 10, quantity squared, what would that be equal to? So this would be equal to the quantity x squared minus 6x plus 10 times the quantity x squared minus 6x plus 10. Let me get rid of these middle steps here because we're going to run way off the page. We don't need that stuff anymore anyway. Let me move this up here like this. So x squared times x squared is x to the 4th power. Then x squared times negative 6x, that's negative 6x cubed. Then x squared times 10, that's going to be plus 10x squared. Then negative 6x times x squared, that's minus 6x cubed. Negative 6x times negative 6x, that's plus 36x squared. Then negative 6x times 10, that's going to be negative 60x. Then here you have 10 times this guy, so you can have plus 10 times x squared is 10x squared. And then 10 times negative 6x is negative 60x. And then 10 times 10 would be 100. Okay, so let's look for like terms. So x to the 4th power, nothing we can do with that. Then if you have negative 6x cubed minus 6x cubed, that's going to be negative 12x cubed. Then if we have 10x squared plus 36x squared, that's 46x squared, then plus another 10x squared, that's going to be plus 56x squared. And then we have negative 60x minus 60x, that's minus 120x, and then plus 100. And let me come back up here, and I'm just going to paste this in. So this is the answer. Again, I know this is a tedious one, but if you use that formula, it's not too bad. So f of x is equal to, again, you can use this if you want, or you could say it's x to the 4th power minus 12x cubed plus 56x squared minus 120x plus 100. All right, for the next few problems, the instructions are going to change. Now we want to find all zeros. All right, for problem 6, we have f of x is equal to x to the 4th power minus 4x cubed minus x squared minus 114x minus 102. We're given 1 0, which is negative 1 plus 4i. Let me come to another page here. I'm just going to write zeros here. So this is going to be the answer for this problem. And we have negative 1 plus 4i. By the conjugate zeros theorem, we know that negative 1 minus 4i is also a 0. So we need 2 more zeros here because we have a 4th degree polynomial. And the way we're going to get them, let me come back up here. We're going to take this guy right here and use synthetic division. And basically, we're going to cut this down to a cubic, and then we're going to cut it down to a quadratic, and then we can use the quadratic formula. So basically, let me set this up as negative 1 plus 4i. And you want to give yourself a lot of room when you do these. So the coefficient for x to the 4th power is 1. Let me leave a decent amount of space here. Then the coefficient for x cubed is negative 4. Then this is going to be negative 1 for the coefficient for x squared. The coefficient for x to the 1st power is negative 114. And the constant is negative 102. Okay, let me bring this to another page. No way that's going to fit here. So let me come right here. And again, you're just going to drop this down and go through this. So negative 1 plus 4i times 1, that is negative 1 plus 4i. When you add these together, you just have to add negative 4 plus negative 1, that is negative 5, and then you just have your plus 4i. Now here comes the tedious part. You need to multiply this by this. So let's go negative 1 plus 4i, and then times negative 5 plus 4i. Okay, so negative 1 times negative 5 is 5. Your outer, negative 1 times 4i is negative 4i. Your inner, 4i times negative 5, that's minus 20i. And then your last, 4i times 4i, that's plus 16i squared. Now, I squared is negative 1, so really you can erase this and just change the sign here to a negative. And so if you think about 5 minus 16, that's going to be negative 11. And then negative 4i minus 20i, that is negative 24i. So that's going to go right here. So you have negative 11 minus 24i. Okay, let me get rid of this. And now we're going to add, and that part's easy. So you just have to do negative 1 plus negative 11. That is going to be negative 12. And then you have your minus 24i. Okay, so now we have to multiply. Again, that's the tedious part. So this times this. So you're going to have negative 1 plus 4i. And then times, you're going to have negative 12 minus 24i. So negative 1 times negative 12 is 12. The outer, negative 1 times negative 24i, that's plus 24i. The inner, 4i times negative 12, that's minus 48i. The last, 4i times negative 24i, that's going to be negative 4 times 24, that's 96. And then I times I is I squared. So once again, I squared is negative 1. So just change the sign of this to a plus. So 12 plus 96, that's going to be 108. And then 24i minus 48i, that's negative 24i. And I'm going to write that we have 108 and then minus 24i. And then we're going to add these guys. Let me get rid of this. Again, that's really easy to do. All you have to do is do negative 114 plus 108, and that is going to give me negative 6. And of course, you have the minus 24i. Okay, so now we're going to multiply this by this. And so you have this negative 1 plus 4i, and then times this negative 6 minus 24i. And so negative 1 times negative 6 is 6. Your outer would be negative 1 times negative 24i, so that's plus 24i. Your inner, 4i times negative 6, that's minus 24i. And then your last 4i times negative 24i, that's going to be negative 96i squared. So this right here is going to cancel. And then again, I squared is negative 1. So this right here would be a plus. What is 6 plus 96? That is 102. So that goes right here. And of course, we should expect that when we get the sum here, that it's going to be 0. Because again, if the remainder is 0, that tells us that this is a 0, but we were already told that this was a 0. This is not new information. The reason we're doing this is so we can get the coefficients for the cubic. Now, you don't have to write it out. You can just take this right here and do synthetic division again. So now what you're going to do is use the conjugate. So you're going to go negative 1 minus 4i, and you're going to set this up like this. And so you're going to copy these. Let me go ahead and copy. So this is going to be your coefficient for x cubed, x squared, x to the first power, and that's your constant. And now we're going to do synthetic division again. So this will be a 0, and we're not really concerned with whether it's a 0 or not. We already know that from the conjugate zeros theorem, but we're trying to get this down to a quadratic where we can use the quadratic formula and find the other two zeros. Okay, so let's put this like this, drop this down. And so negative 1 minus 4i times 1, that's negative 1 minus 4i. So now you're going to add, and negative 5 plus negative 1, that's negative 6. 4i minus 4i is 0. So this is just negative 6. So now you're going to multiply negative 1 minus 4i times negative 6. Let's do that right here. So negative 6 times negative 1 minus 4i. So negative 6 times negative 1 is 6. And then negative 6 times negative 4i is plus 24i. So this is 6 plus 24i. Let me get rid of this. And now we're going to add. So negative 12 plus 6, that's going to be negative 6. Notice that negative 24i plus 24i, that's 0. So we're going to do negative 1 minus 4i times negative 6. We just did that a moment ago. We know it's going to be 6 plus 24i. And of course, when you add these guys together, negative 6 minus 24i plus your 6 plus 24i, that is going to give you 0. So that is not a surprise because we knew this was a 0. At this point, this right here is going to give you your quadratic. So this 1 right here is the coefficient for x squared. So x squared, then you have minus 6x, and then minus 6. And let me come back here. All you need to do is set this equal to 0 and solve. And in this case, you're not going to be able to factor it, so you can just use the quadratic formula. So your a is 1, your b is going to be negative 6, and your c is also negative 6. So your x is equal to, again, the negative of b plus or minus the square root of b squared minus 4ac all over 2a. So what is b? b is negative 6. So the negative of negative 6 is positive 6. Then here, negative 6 squared is positive 36. Then for a, you have 1. So you can just erase that. Your c is negative 6. So let's go plus negative 4 times negative 6. What does that give me? Negative 4 times negative 6, that's positive 24. Let's put 24 there. And then 2 times a, again, a is 1. So what is 36 plus 24? That is going to be 60. So this would be equal to 6 plus or minus. If you think about 60, it's 15 times 4. Let me erase this and just put 15 times 4. We know 4 is a perfect square, so you can say this is 2 times the square root of 15. This is over 2. Now, you can factor out a 2, so we can say this is equal to 2 times the quantity 3 plus or minus the square root of 15 all over 2. And so now we're going to cancel this 2 with this 2. So let me write this as 3 plus or minus the square root of 15. So one zero would be 3 plus the square root of 15, and the other would be 3 minus the square root of 15. So that's what we're looking for in terms of the zeros. That's the process overall. I know it's quite tedious, but you will be asked to do it in this section. All right, for problem 7, we have f of x equals x cubed minus 7x squared plus 17x minus 15. The zero given is 3. So in this case, all you have to do is some simple synthetic division. We're going to put 3 out here. And then we're going to take this as a 1 for the coefficient for x cubed, this as a negative 7 for the coefficient for x squared, this as a 17 for the coefficient for x, and then your constant is negative 15. So we're just going to drop this down like this. 3 times 1 is 3, and negative 7 plus 3 is negative 4. 3 times negative 4 is negative 12. 17 plus negative 12 is positive 5. 3 times 5 is 15. Negative 15 plus 15 is 0. All we're doing is we're getting these guys right here so we can set up our quadratic, and then we can just use the quadratic formula. So this is the coefficient for x squared, and then you'd have minus 4x, and then plus 5. And I'm just going to write in zeros, plural, so we know 1 is 3. Let me paste this in right there. Let's say this equals 0 here. So let's go ahead and solve this. Can we factor this? So we need two integers that sum to negative 4 and have a product of positive 5. Well, with positive 5, you either have 1 and 5, 1 plus 5 would be 6, or you have negative 1 and negative 5, that would be negative 6. So we're not going to be able to solve this with factoring. So again, we're just going to go to our quadratic formula. So this is a 1, let's go plus negative 4, and this is a 5. So A is 1, B is negative 4, and C is 5. So we have x is equal to, again, the negative of b plus or minus the square root of b squared minus 4ac all over 2a. So let me put a little border here. We have x is equal to, what is the negative of b? B is negative 4. So the negative of negative 4 is positive 4. Then plus or minus the square root of b squared. Negative 4 squared is 16. Then minus 4 times a times c. A is 1, so you can forget about that. So let's just go plus negative 4 times c is positive 5. So this right here, negative 4 times 5, that's negative 20. So this is negative 20. And 16 minus 20 would be negative 4. So this is negative 4. And then this is over. 2 times a is 1, so this is just 2. So let's simplify. So we know that the square root of negative 4, we can write that as 2i. So let's say that this is 4 plus or minus 2i over 2. And of course, we can simplify this. So we would say that we pull out a 2, and this would be 2 plus or minus I over 2. And then let's cancel this 2 with this 2, and we'll say that it's 2 plus or minus I. So I'm just going to say it would be 2 plus I, and then of course 2 minus I. All right, let's take a look at problem 8. So we have f of x equals x cubed minus 8x squared plus 6x plus 52. The zero we're given is 5 minus I. So let me come over here, and let me put zeros, 5 minus I, and of course you'd have 5 plus I, and you'll have one more, again, because this is a cubic, so you'd have 3 zeros. Let me come up here, and again, we can just use synthetic division. There's lots of ways you could do this. So I'm just going to start with 5 minus I here, and then leave lots of room. So we're going to have a 1 here. This is negative 8. Then this is going to be a 6, and this is going to be a 52. And let me drop this down here like this. So 5 minus I times 1 is 5 minus I. So you're just going to add negative 8 plus 5. That's going to be negative 3. So this is negative 3 minus I. Let me fix that. And then you just need to multiply these guys together. So 5 minus I times negative 3 minus I. And so this would be 5 times negative 3, that's negative 15. 5 times negative I, that's minus 5I. Negative I times negative 3, that's plus 3I. And then negative I times negative I, that's plus I squared. We know that I squared is negative 1, so you can just say that this is minus 1 here. And so negative 15 minus 1, that's negative 16. And then negative 5I plus 3I, that's negative 2I. So let's go ahead and say that this right here is going to be negative 16 minus 2i. And let's say that 6 plus negative 16 is negative 10, and then minus 2i. So now we have 5 minus I, and then times this negative 10 minus 2i. So 5 times negative 10 is going to be negative 50. And then you have 5 times negative 2i, that's negative 10i. And then negative I times negative 10, that's plus 10i. And then negative I times negative 2i, that's going to be plus 2i squared. Again, I squared is negative 1. So let's flip this to a negative here. And then basically this is going to cancel. So negative 50 minus 2, that is negative 52. So this is negative 52. Again, that's not a surprise. We were already told that this was a 0. So this is a 0. And I'm just going to highlight that. So now we have a quadratic, but we do not have real coefficients. So we're not going to use the quadratic formula. We're just going to use synthetic division again. So we're going to go 5 plus I now. And we're just going to use this right here. So 1, you have negative 3 minus I, and then negative 10 minus 2i. Let's drop it down and bring this down here. And let's go ahead and say that 5 plus I times 1 is 5 plus I. So negative 3 plus 5 is positive 2. Negative I plus I, that's going to cancel. So 5 plus I times 2, let me do this over here. So 2 times the quantity 5 plus I. This is 2 times 5, which is 10, plus 2 times I, which is 2i. So this is 10 plus 2i. Again, we already know this is a 0, so it's not a surprise. So if we have negative 10 plus 10, that's 0. Negative 2i plus 2i, that's 0. So this is 0. Again, we know there's no remainder. So this right here. Well, we had a quadratic, so now this is going to be a first degree. So this is just x and then plus 2. That's all it is. Let me come up here, and all you'd have to do is say x plus 2 is equal to 0. And of course, that would be x is equal to negative 2. So negative 2 would be your other 0. So the zeros here, you have 5 minus I, and then 5 plus I, and then you would have negative 2. All right, let's take a look at problem 9. So we have f of x is equal to x to the 4th power minus 4x cubed plus x squared plus 6x minus 40. We're given a 0 of 1 plus 2i. Let me come down here again, and let me write zeros. So if 1 plus 2i is a 0, let me write that one. So 1 plus 2i. Again, by the conjugate zeros theorem, we would have 1 minus 2i as a 0. Let's come back up here. Again, we're just going to stick to our synthetic division. So let's go ahead and say that this would be 1 plus 2i over here. And again, I want to leave myself a lot of room. So this would be a 1 right here. And let me leave myself some space and go negative 4. And then this would be a 1. This would be a 6. And then this would be negative 40. Extend that a little bit. And we can just do this right here. I'll just drop down and bring that down. And then let's start. So 1 plus 2i times 1 is just 1 plus 2i. So then negative 4 plus 1, that's going to be negative 3. So this is negative 3 plus 2i. So now we have to do 1 plus 2i times negative 3 plus 2i. 1 times negative 3 is negative 3. And then we have 1 times 2i, that's plus 2i. And then we have 2i times negative 3, that's minus 6i. And then we have 2i times 2i, that's plus 4i squared. So of course, you can just write this as minus 4 here because I squared is negative 1. So you have negative 3 minus 4. That is going to be negative 7. And then you have 2i minus 6i, that is negative 4i. So this right here would be negative 7 minus 4i. And now we're going to add 1 plus negative 7. That is going to be negative 6. And then you have minus 4i. So we're going to multiply 1 plus 2i. So 1 plus 2i. And then times negative 6 minus 4i. This is 1 times negative 6. That's negative 6. And then you have 1 times negative 4i, that's negative 4i. And then 2i times negative 6, that's minus 12i. And then 2i times negative 4i, that's minus 8i squared. So this equals. So this I squared is negative 1, so this is just going to flip the sign. So this would be a plus. Negative 6 plus 8, that's going to be 2. So this is 2. And then we have negative 4i minus 12i, that's going to be minus 16i. Okay, so let me put this right here as 2 minus 16i. And we're going to go 6 plus 2, that is 8. And then you have minus 16i. So we would have 1 plus 2i. Let me fix this plus here. And then times 8 minus 16i. So 1 times 8 is 8. The outer would be 1 times negative 16i, that's minus 16i. The inner would be 2i times 8, so that's plus 16i. And then the last 2i times negative 16i, that is negative 32i squared. This right here is going to cancel. And then I squared is negative 1, so you can just flip this to a plus. So 8 plus 32, that is 40. So this is 40. Again, that's as expected because we already know that this is a 0 because it tells us that in the problem. So this is a 0. Again, the reason we're doing this is to get this down to a quadratic. Right now it's a cubic, so this would be your coefficient for x cubed, x squared, x to the 1st power. Again, this would be the constant. So basically, you just do synthetic division again with the conjugate of this. So 1 minus 2i. And we're just going to take this right here. So 1 negative 3 plus 2i, and then you have negative 6 minus 4i, and then 8 minus 16i. So let's drop this down right here. So we have a 1, and then 1 minus 2i times 1 is 1 minus 2i. So negative 3 plus 1, that is going to be negative 2. 2i minus 2i is 0, so this is just negative 2. Then 1 minus 2i times negative 2, that's negative 2 times. You have 1 minus 2i like that. Negative 2 times 1 is negative 2. And then negative 2 times negative 2i, that's plus 4i. So this is negative 2 plus 4i. So now we have negative 6 plus negative 2, that is negative 8, and negative 4i plus 4i, that's 0, so that's going to go away. So now we're going to multiply negative 8 times this 1 minus 2i, and this would be negative 8 times 1, that's negative 8, and then negative 8 times negative 2i, that's plus 16i. So this is negative 8 plus 16i. Again, if you add those guys together, this 8 minus 16i, and then plus this negative 8 plus 16i, that is 0, again, as expected. So we're just going to take this, and we're going to get a quadratic out of it. So this is for x squared, and then this is minus 2x, and then minus 8. So we're just going to grab this. Okay, let's bring this back right here, and I'm just going to set this equal to 0. This is actually one you can solve with factoring. It's pretty easy to do. You can use the quadratic formula if you want, that's up to you. But I'm just going to put an x here and an x here, two integers that sum to negative 2 and have a product of negative 8. That's going to be negative 4 and then positive 2. Okay, let me get rid of this. And again, by the zero product property, you would just say x minus 4 is equal to 0, or x plus 2 is equal to 0. Let me get rid of this. Add 4 to both sides of the equation here. This cancels, you get x is equal to 4. Then over here, we're going to subtract 2 away from each side of the equation. This cancels. You're going to get x is equal to negative 2. So we can just throw those in as zeros. Let me fix this I here, make it a little bit better. So another 0 would be 4, and then another 0 would be negative 2. So if we look at all the zeros, you have 1 plus 2i, and then the complex conjugate, which is 1 minus 2i, and then you have 4, and then negative 2. All right, for problem 10, we have f of x equals x to the 4th power plus 2x cubed minus 22x squared minus 30x plus 153. We're given 1, 0, which is negative 4 plus I. Let me come down here and just put zeros. So we have negative 4 plus I, and then of course you'd have negative 4 minus I. Let me go back. And again, we're just going to follow that same procedure. We're going to use synthetic division to get this down into a cubic, and then we're going to go down to a quadratic, and then from there we can just use the quadratic formula. So let's write this as negative 4 plus I, and let's set that up like that. And you just want a lot of room here, so we're going to take a 1, that's the coefficient for x to the 4th power, and then 2, that's the coefficient for x cubed. And then you have negative 22, that's your coefficient for x squared. You have negative 30, that's your coefficient for x. And then you have 153, that's going to be your constant. And let's drop this down. We'll say that this is 1. Negative 4 plus I times 1, that's just negative 4 plus I. Well, 2 minus 4 would be negative 2. So let's say this is negative 2 plus I. So now we're going to do negative 4 plus I, and then times negative 2 plus I. So negative 4 times negative 2 is positive 8. Negative 4 times I would be minus 4i. Then I times negative 2, that's minus 2i. And then lastly, you have I times I, which is I squared. So plus I squared, which of course is negative 1. So you can just put minus 1. So this would be equal to 8 minus 1 is 7. And then negative 4i minus 2i, that's negative 6i. So this right here is going to be 7 minus 6i. So then negative 22 plus 7, that's going to be negative 15. And then you have this minus 6i here. So now we're going to multiply. So we're going to do negative 4 plus I, and then times negative 15 minus 6i. So negative 4 times negative 15, that's positive 60. And then your outer negative 4 times negative 6i, that's going to be plus 24i. Your inner I times negative 15, that's negative 15i. And then for the last, you have I times negative 6i, that's going to be minus 6i squared. So I squared is negative 1. So we're just going to change the sign of this to a plus. So you have plus 6 there. So 60 plus 6 is going to be 66. And then you have 24i minus 15i. That's going to be plus 9i. So this right here would be 66 plus 9i. Then we have negative 30 plus 66. That is going to be 36. And then you have plus 9i. And then let's multiply. So we're going to have negative 4 plus I, and then times 36 plus 9i. So negative 4 times 36, that's going to be equal to negative 144. Then negative 4 times 9i, that's minus 36i. Then I times 36, that's plus 36i. And then I times 9i is plus 9i squared. Okay, so this is going to cancel. I squared is -1, so you can just change this to a minus. So -144 minus 9, that is going to be -153, again, as expected. So you put -153 here. Let's get rid of this. And of course, when you add those guys together, your 153 and your -153, let me slide this down a little bit, that's going to give you 0. So again, that's not a surprise. We already know the remainder would be 0 here because we were told that -4 plus I is a 0. What we're going to do now is grab this right here. So this would be the coefficient for x cubed, x squared, x, and the constant. And we're going to do synthetic division again. So now let me write -4. Again, instead of plus I, you want minus I. So that's, again, coming from the Conjugate Zeros Theorem. And we're just going to grab this. So you have 1. Let me use a little space. You have -2 plus I. Then we have -15 minus 6i, and then you have 36 plus 9i. Okay, let me drop this down like this, and let's say -4 minus I times 1, that's -4 minus I. So -2 plus -4, that's going to be -6, and then I minus I is 0. So now you have -4 minus I times -6. So -6 times the quantity -4 minus I. This would be -6 times -4, that's 24. And then -6 times -I, that's plus 6i. So this is 24 plus 6i. Let me get rid of this. So -15 plus 24, that's going to be 9. And then -6i plus 6i, that's 0. So then -4 minus I times 9, that's going to be 9 times the quantity -4 minus I. So this equals 9 times -4 is -36. And then minus 9 times I is 9i. So this right here would be -36 minus 9i. So of course, when you add these guys together, you're going to get 0. 36 minus 36 is 0. 9i minus 9i is 0. So this is not a surprise. We know that this would be 0 for the remainder because we know that -4 minus I is a 0 if -4 plus I is a 0. Okay, so now we have a quadratic. So this is for the coefficient for x squared. So it would just be 1x squared or x squared. And we would have -6x and then plus 9. Okay, let me paste this in here and set this equal to 0. So for this one, you can factor it. This would factor into x minus 3 quantity squared. And you can say that's equal to 0. Again, that's coming from the fact that -3 times -3 would be +9, and -3 plus -3 is -6. Now, with this guy right here, you're going to have a double root. In other words, because this is squared, you could write this as x minus 3, the quantity, times x minus 3, that quantity, is equal to 0. And so if you solve x minus 3 is equal to 0, you add 3 to both sides of the equation, and so you get x is equal to 3. Now, depending on how the question is asked, you might only have to put, because if it just says, what are the zeros, you just put a 3 in there. Now, sometimes they're more specific, and they might say, what are the zeros and their multiplicities? So if that comes up, then you would want to modify the answer to say that this right here has a multiplicity that's 2. Okay, so it just depends on the situation. Just read the instructions carefully. If they just ask for the zeros, most of the time they'll just say, okay, well, it's -4 plus I, -4 minus I, and then 3. If they ask for the zeros and the multiplicities, then you want to say -4 plus I, -4 minus I, and then you would say 3 with a multiplicity 2.